streaming. There it is. Got it. And then make sure that I don't start streaming. There it is.
No, thanks.
Echoing back. Okay. So good evening, everybody, and welcome to the February meeting of Palomar Amateur Radio Club. My name is Joe, K6JPE, your president, and we will get things started with, I don't remember if I'd done this yet. I talked about it, but I don't remember if I actually did it. I was at a fundraiser, and the Marine Mounted Color Guard was there and did the flag ceremony at this fundraiser over here in Oceanside. So there is only one mounted color guard in the Marines. They travel all over the country, and they were here in Oceanside. I think it was before Halloween, so it's been a while, but sometime in September or October. But at any rate, we have our flag here. So if everyone would please remove your cover if you're wearing one, and we'll join in the pledge. I pledge allegiance to the flag of the United States of America, and to the
republic for which it stands,
one nation, under God, indivisible, liberty and justice for all. All right. Thank you all. It's the second time in the last hour that I've done the pledge. I had my son's Cub Scout meeting here, and we did a flag ceremony in the backyard to get an advancement for some of the scouts who had not done one yet. So that was kind of fun. So yes, that's why I was not here for the pre-meeting banter. I was attending to the young ones. All right, we will get things rolling here. Hey, Mark, do you have anything to talk about tech-wise? We lose Mark.
Mark, you muted, Mark.
Sorry, I went back into hiding. I don't think that the General Club is aware, but I was able to pick up a spare Yaesu repeater. Same model as all the ones that we have on the hill, so we now have a spare. Yay. Yeah. That's about the only thing of interest. All the repeaters. We had a pretty nice sized earthquake up here the other day. It hit just a couple miles from the repeater site. Glenn and I got on, and hasn't destroyed anything that's transmitting, at least, but I haven't made it up on the property to see whether or not boxes have fallen over and things. I had one box fall over here at the house, but it was kind of teetering to start with, and it was filled with old dead light bulbs, so it wasn't exactly a catastrophe. But anyway, we'll make a trip up there soon. The weather's been incredible. The repeaters are behaving well, and life is beautiful all the time.
Fantastic. Thanks for that, Mark. I went and skipped over the visitors. So any first-time visitors joining us here? I see a couple of people that I maybe don't recognize besides Ryan, but we'll get to Ryan later. Any other first-time visitors haven't joined us at a meeting yet? Hey, you are not a first-time visitor, Richard. All right, well, if you are here for the first time, welcome, and we won't put you on the spot. How about new hams, brand new hams? Anyone want to talk about the licensing or just getting an upgrade maybe that we can congratulate you for? No? Okay. Announcements. I don't have anything beyond what was in the scope, which went out to email recently. Hey, Mike and Gail, did you get the scope this time? Did that get ironed out?
Nope. Gail got it.
Oh, what's that?
Gail got one. I didn't get one.
Huh. Okay. Well, that's better than we were doing last month, right?
I think she always got them, didn't you know? Yeah, she always got them.
Okay.
I never got them.
I'll go look at that again. It will show up on the website here probably during the meeting. I'll get the website updated to have the link to the most current scope there under newsletters. A couple of announcements in the newsletter about silent keys recently. And, sadly, we're losing hams that are active in the community and don't seem to be adding them at the best rate. So your board is working on ideas for upping participation. Some of that is going to come from scouting. I actually was just talking to the den leader about getting the scouts on the scout net, which would have been about half an hour ago now. So in 2 weeks, we'll be doing that from the house here. And so that'll be fun. Okay. Membership. Glenn?
Okay, so as everyone, well, not everyone that's on knew this, but my wife Sandy and we went on a little trip last October, and between the dog and the snake, and she fell and broke her arm, and it took a long time to get the splints and cast and the other cast and the other splint off. So it really interrupted life, but I finally got busy, sent out reminders for dues for a number of people whose memberships expired during that time, and had a pretty good response. So I've got 4 more payments I've gotten in. I don't know if these are extensions or brand new people. I haven't looked at them yet, but we are now back up to 149 members. We were down to 128 the last meeting. And I think that's all I've got.
I just noticed that I can do an immersive view. So I switched that just to see what that would look like. So you may see something change on your screens to everybody sitting in a classroom environment. I just thought I'd play with that and see what it looked like.
We
All
got
right.
Phil Jr. over there in the little tiny chair.
Put us in a instead.
Yeah, well, most everybody works well. Some people apparently don't have the ability to mask out their backgrounds, but yeah, that's neat. Anyway,
That's pretty cool.
Yeah.
You should see Michelle. If you want cool, you should see Michelle.
Oh, yeah. Michelle has the neat filter going on, cartoonized. Okay, I'll switch you back to speaker view. Okay, so let me see where we are. As always, if you have any questions or comments for the board, you can contact us, board@palomararc.org. There's also contact info on the website. And there's a phone number on there that can receive text messages that just go to the board email address. So if you choose to want to communicate that way as well. All right, introducing. Oh, there's I have goodie table on my agenda, but we don't have a goodie table because we're virtual. But there is a goodie table in the scope. There's some items that we're looking to rehome. So take a look at this month's scope for those items that we want to get out of some garages and into somebody else's garage. So your board. We have Charlie NN3V as your repeater site chair and heading up our modernization effort, getting some new technology up on the mountain. Mark KF6WTN is your repeater tech chair, working very closely together there, Charlie and Mark. Keith is your scope editor, KM6CXW. As always, if you have anything that you want to include in our newsletter, please email them to scope@palomararc.org, and Keith will get that in. We're looking for a sooner deadline, so February 20th, I think, is the deadline this month. We're trying to get the scope out at the end of the month so that it's enough in advance of the general meeting. Your directors are KD9LF Chris and AJ6FQ Ron. Your membership chair Glenn AI6RR. Treasurer Jim W, K2VO, Secretary Jim C, W6TQS, Vice President Michelle, W5NYV, and I am your President, Joe, K6JPE. And we will now turn it over to our speaker. Let me make sure I can pin the correct speaker. So I'm going to go back to the gallery view and then pin and nope, that didn't work. I need to spotlight for everyone.
Joe, would you like me to introduce the
Oh,
first
sure. Go ahead. Yeah.
Okay, it'll be Mark Moede will be leading
Oh, sorry.
oh, no problem.
Okay.
He'll be leading us off this evening. And Mark Moede, he graduated from the University of Wisconsin, Madison with a Bachelor of Science in Meteorology in 1983. After graduation, he worked in private sector meteorology until 1991, and then joined the National Weather Service in Green Bay in 1991. Real weather. That's where he learned about radiosondes and launched weather balloons. In 1995, he accepted a job at the NWS office in San Diego, and he's been here ever since. He is one of 5 of the lead forecasters in the San Diego office. He is the heat program leader with a focus on forecasting and messaging heat wave intensity and duration to the public and to emergency management partners in Southern California. He is also the tsunami program leader in his office, and he is going to explain to us about radiosondes from the National Weather Service point of view. Please welcome our first speaker, Mark Moede.
Thanks, Michelle, and thank you for the invitation to speak to your club. I moved here in San Diego from Green Bay, and it was wonderful to not have winter, where the temperature actually fell below 0. Those days were hard. If any of you have ever lived in the upper Midwest, Great Lakes, or New England, you know what I'm talking about. But living out here, it's great. Our office is wonderful, and I've been at the office now for since 1995. We had our office located at the airport, and I was there on the very last day. We were moving out of the airport office and up to our new office at the time in Rancho Bernardo, which is where the National Weather Service office in San Diego is located, up in Rancho Bernardo. So what I'd like to share with you today is our radiosonde operation. I know Ryan is an avid follower of collecting and searching and looking for radiosondes and finding them and returning them. And we do use and recycle those radiosondes. They cost on average or anywhere from $250 to $500. And if we get them back, we get a chance to recycle them and use them again, saving taxpayer dollars. So I would like to start out with a presentation here on a few slides of the radiosonde operation. I'll share my screen here. And I'm hoping you'll all be able to see this screen. On the screen is our auto launcher project. This is
We see it.
great. This was installed just a couple of years ago. The balloon launch is at the Miramar Naval Air, the Miramar Station, where the 163 and the 15 divide or merge. And our station is there, and we used to manually launch weather balloons. We'd have individuals go there, inflate the balloon, prepare the radiosonde, and launch it manually. Well, a few select stations, most of them in Alaska and now some in California and the West Coast, were assigned to an auto launcher project, an experimental program where it was all completely automated. We actually launched the balloons now from our office in Rancho Bernardo, all through this auto launcher project. And this is what it looks like. And here is what the interior looks like as well.
So you actually picked a snowy day
Yeah.
picture in San Diego?
Actually, I must take that back. This was during the testing phase in Sterling, Virginia. And we sent our techs out there. In fact, you'll see some pictures of the people there involved in the testing and of the project itself. So let's see, I'll see if I can get over to the next slide. And here it is. This is the automated radiosonde observing system. And again, this is all done by computer. we initiate the launch process. It inflates the weather balloon there with hydrogen. Here's what it looks like inside the operator room, where the site operator loads the machine and monitors the system. So there's a circular bin here, and it's loaded. This is the computer monitor screen. I'm going to go one more slide forward to give you an idea what it looks like. Here is the inside of the mechanism, and there are 24 launch trays. And this was our electronic technician. His name is Mike Lauderdale. And he was preparing all 24 bins for launching. So they have to be reloaded about once every couple weeks. And you can see the entire mechanism. Here's the radiosonde, here's the weather balloon, and the hydrogen tanks are in another room with piping fitted to initialize the inflation of the weather balloons at the specified time. We launch them twice a day. Both times are at 0Z, 0 UTC, global time. So what happens is, all around the world at the same time, twice a day at 0Z and 12Z, balloons are launched, weather balloons are launched all over the world. And so these weather balloons are launched and they gather data of the atmosphere from the surface up to where it bursts, which amazingly enough is about 100,000 feet. You're at the very near the top of the atmosphere there. The pressure is anywhere from 5 to 10 millibars, and you're getting close to outer space. So as the balloon goes up, it collects temperature, pressure, moisture, and wind speed data from the surface all the way to the top of the atmosphere. And then what this weather instrument does, this radiosonde does, it collects all this information, sends it back to our computer, which then we send to the national headquarters in Washington, DC. Us with 92 other stations in North America, and then the rest of the stations around the world, all the data at the same time is ingested into a computer. The computer puts all this information into gigantic mathematical formulas, and basically you have a mathematical equation set around the world of each of the layers of the atmosphere from the surface to about 10 millibars. And from there, the computer takes that data and projects it out into the future. 3 days, 5 days, 7 days. Now, when I first started, a 5-day forecast to get it right was quite challenging. Nowadays, the 7-day forecast is actually becoming fairly quite good in relation to what it was just 30 or 40 years ago. So as improvements in computer technology continue to move forward, we'll see continued improvements, I believe, every decade as we go forward. From the 60s to the 70s, we saw improvements, 70s to the 80s, and so on and so forth. And as the computing process and the algorithms used to program the weather get better and better, we'll see continued improvements over time. Does anybody have any questions at this point on the radiosonde and how it's set up for launch?
Peripheral question, possibly.
Okay.
Back in college, I did a little bit of work on predicting the weather, and we were using Fourier analysis. Is that still the technique that's being used now?
It very well may be. We took very intense mathematical classes, math, physics, and calculus, and some computer science. And we did deal with those deep mathematical equations that we had to derive and solve.
Basically, it ends up being a series of sines and cosines that, God help you, go on forever. Essentially,
yeah. From the multiple layers of the atmosphere broken down into very small layers. And yeah, those are some of the processes I recall having to study and then learn. But then once we finished the class, then it was essentially, if you wanted to go into computer programming and programming weather equations, then you would continue to work on that in the research field. But the other aspects of it are to go into forecasting meteorology and broadcast meteorology.
I just wanted to make sure you hadn't changed the base rules on me. I remember our granularity back in the 80s was not exactly the way it could possibly be now. So thanks.
I'd like to show you, I'll stop with this slide here. This is the detailed schematic of the automatic release system. May be kind of hard to read. This is the real technical stuff, the electronics and the structural aspects of the AROS equipment. So now what I'd like to do is show you a sounding from last Saturday. Now, are you able to see the sounding?
No, it still has the same window
Okay.
for the AROS.
Okay, thank you. Let me fix that. And this should take care of it. Okay.
Yeah, that's the one.
Does this look familiar to anyone? This is the actual output from a radiosonde. So this is the data it returns back to us. The red line is the temperature. We launched the radiosonde at the surface, which is approximately 1,000 millibars. And the red line is the temperature. It goes up through the atmosphere. It's the tropopause, and then temperatures actually start warming as you get way up above the jet stream level. The green line is the dew point, which is the measure of the amount of moisture in the atmosphere. And you can see as it goes up here, the closer the red and the green lines are together, the higher the humidity. So here at the surface, this was during a Santa Ana period. The winds are on the right-hand column. So you can see the wind here was easterly from about 1,000 feet to around 6,000 feet. So the lowest layers of the atmosphere, we had a Santa Ana wind at the surface. When we have Santa Ana winds, we all know that it brings very dry air. And there's a large spread in the temperature and the dew point trace. Very, very dry atmosphere. However, we had this was on Saturday. Saturday was a day where it was a lot of mid-level and high-level clouds. And there was a lot of moisture. If you looked at the sounding, you would see this temperature and dew point line very close together, meaning there's a high humidity. And there were actually quite a bit of mid and high-level clouds on Saturday. And if you were looking up, we had some beautiful sunsets, by the way, sunrises and sunsets on this day. And there was actually so much moisture aloft that was actually producing virga. And virga is actually rain and snow and ice crystals that fall to the ground, but evaporate before they reach there because the atmosphere below is so dry. And that's what was going on today. So Friday was a very sunny day. Saturday was kind of a partly to mostly cloudy day with virga. And Sunday and Monday were generally sunny days. And in fact, I think we're going to be in a very dry Santa Ana type pattern here for the next 10 days. So this is the output that we got from the sounding. And I wanted to share one more image of the day. This was the actual radar. Let's see if I can get it to play the loop. This was Saturday's radar. Now this looks pretty impressive on radar, doesn't it? It looks like it's raining. In fact, though, the radar returns were being reflected off the clouds, the ice crystals, the virga that was falling. They made it look pretty ominous, but as long as you knew the profile of the atmosphere based on what we got from the radiosonde, you knew that this was just high-level clouds and some virga falling and evaporating before it hit the ground. There may have been a few sprinkles. Maybe Palomar Mountain did see a sprinkle, if anyone was up there, but all of the moisture just evaporated before it reached the ground. So I can tell you a little bit about what it was like to launch weather balloons in Green Bay. Are there any questions on what I've shown so far?
I have
Did
one.
you show the video of it launch? I didn't see that if you did.
Did anyone see that?
No,
No.
No, it didn't show? Oh, well, let me try it again then. Yeah, it looks like it looks like it went away. I'm sorry. It was a radar loop.
That's okay. We can get it set up on the website and on our Facebook group. So we'll work on that as a follow-up. And I think Paul had a question.
what frequency band are you using this down?
Sorry, I didn't quite catch that.
I wonder what frequency band you're communicating down to the ground with.
That I can't answer. In fact, maybe Ryan might be able to answer that one better than I would.
Yeah, I
We're
think,
definitely going to go into depth on that after Mark's done talking about the weather side of things. And I'll drop in the chat a link to a YouTube video of one of those launchers actually releasing the balloon. So if after the meeting you want to have a look at that.
Thank you. All right, any other questions?
Okay, let me try mine again. Can you explain the significance of the diagonal grid pattern on that chart?
Let's see. Let me see if I can bring it up again. And you were looking at, is this the image we're talking about?
Yes, that's the one.
Okay. And the question was the diagonals?
That's right.
Oh, it's just the way the atmosphere is profiled on an upper air sounding. They use a logarithmic scale here, and so they have, that's why it's shaped the way it is. The diagonal lines to the right are the temperature, and the diagonal lines, the faint diagonal lines to the left, are actually the pseudo adiabatic cooling trend. So you have a dry adiabatic lapse rate, which is the temperature at which air cools, dry air cools as it rises, and the moist adiabat is the temperature at the temperature rate at which the atmosphere cools if it's not dry, because there's moisture associated with it. So there's a lot into these skew T log P diagrams. It's actually almost like an entire 4-week class on determining, on being able to understand and gather a lot of information that's available in this chart and how it's used to understand the profile of the atmosphere.
Yeah, there's a lot packed in there. I didn't even notice the wind keys over on the right until you pointed them out.
Yeah, this was a very interesting period because the winds they basically shifted direction as you go higher in the atmosphere. So if you're flying an airplane, if you're taking off from the airport at San Diego's International Airport, pilot's taking off and he's got basically, this is about a 10 or 15, 20 knot wind as he goes from the surface to about 5,000 feet. Well, then once he gets up above that layer, the winds turn weakly south. And then all of a sudden, 500 millibars here is about 25,000 feet or so. All of a sudden, if he's heading to the east, he's going to have a wonderful tailwind as he gets up in the jet stream because you have a southwest wind here. This is about 30 knots. Here's jet stream level up here. He'll have a tailwind of about 50 knots. So they actually use these the jet stream to either conserve fuel. If they have a nice tailwind, they'll go into the jet stream and let it push them along. And if they're heading from east to west, they'll actually try to avoid the nose of the jet, maybe fly a little bit farther south or farther north to avoid the strong headwinds that they encounter as they head to the west coast.
So I have a question about the wind direction, is that just determined by GPS readings and how it's shifted from moment to moment?
Essentially, it's exactly right. Yeah. I did have a wonderful experience that was really surprising when I was working in Green Bay. It was a summer day, and we had a dome of high pressure overhead, which means when you have a high pressure ridge overhead, the winds aloft are fairly light. There isn't a lot of wind. So the balloon essentially went straight up in the atmosphere and went up, and I launched it at 5 in the morning and went back in the office. I monitored the balloon launch, tracked it, and then the balloon burst and we got all the data and we sent it out. Well, my shift was over at around 1 o'clock in that day. And around 12:30, there was a knock at the front door of the office. And this gentleman had, he had something in his hands, and he said, I saw this land in my field, and so I had to come to Green Bay anyway. I live about 25 miles away, but I just wanted to return it to you because it says it's the National Weather Service's property, and I knew where you were, so here you are. And so each radiosonde that's brought up has a mailing packet inside of it. And you pull up this mailing packet, and it has the date and the time and the name of the person that launched the weather balloon. And you can find these and drop them in a mailbox anywhere, and they'll be returned and reused. Well, I opened it up and I was like, I cannot believe this. This is the balloon I launched this morning at 5 a.m. Had my name on it. So that was a really cool day.
I'd like to make a comment about the vertical axis on these SQT plots. Although it's logarithmic in pressure, the atmospheric pressure of the Earth decreases exponentially at altitude, so it's pretty much linear with altitude. So halfway up is, doing this on the graph is halfway up to the top of the sounding.
Yeah, they've done their mathematical analysis. These sounding profiles have been around for a long, long time. Prior to 1900, they were launching some type of weather balloon, and they really became very handy in World War II when they were launching weather balloons in Europe and played a key role in the D-Day invasion forecast that is now somewhat famous, as the forecaster in charge there said, we can do it on this day. It'll be choppy, but we can do it.
I have a question, Mark.
Sure.
What's the next step or the next evolution in radiosondes? Are we set for a while with these automated launchers, or is there any big shifts coming up in the way that they're done or the way that they're built?
We just the balloons, the weather radiosondes that I launched when I was doing them in the 90s, they were a lot larger. They were boxy, fairly big rectangle. They've shrunk in size quite a bit. They're a lot lighter, a lot more compact. I don't think the weather balloon and the radiosonde are going to be going away anytime soon. We are supplementing the computer data with satellite interpreted atmospheric profiling, but it's just not as precise as the data that we get from weather balloons at this time. There may be a time in the future there. There's a Phil showing an image of a recent radiosonde. And Ryan's got something out there too. And so we get a lot of data void, across the ocean, of course, where there are some ships launch weather balloons, but it's supplemented by the satellite interpreted data that's derived and then also added into the supplemental data is added into the computer program. So more and more time goes by, we're getting a denser network, and more data is flowing into the computer program. And then that in turn, more data generally means a denser network and more accurate profiling of the atmosphere at the initial state, which then makes for a more accurate forecast 1, 2, 3, 7 days down the road.
So I have another question, this is Glenn. So if you launch everything at 0 hours and 1200 hours, So some are launching in the middle of the night, some are in the middle of the day. Is the idea that as they drift, they basically cover the globe because they all launch at the same time?
Yeah, essentially, that's the case. They made an international agreement also for data sharing across the world, and just to have that network of data all at the same time is very important to the initialization of the programs.
And just to clarify on that a little bit, they don't actually go, the individual sonde does not go around the globe. They only go up to a couple hundred miles. But the idea is you have a model of the entire world. You have these radiosondes being launched at all these different points around the world, and it's at the same time. So you end up with, you know, like a 3D wind model of the atmosphere.
Okay, thanks.
So these days, what is roughly the density of the grid? I mean, obviously, you can't have as many launches over the oceans, unfortunately, but what's the density of the grid over land these days, and how do you get data over the oceans?
Yeah, the data over the oceans is limited to the ships, military or Navy vessels that are out there launching balloons on their tasks. And then the other way we get data over the oceans is from satellite imagery, satellite interpretation, and profiling of the atmosphere, which is getting better and better also every year.
Do any reports come in from airliners?
Yes, and we also do have some drop zones from the aircraft. They've also put on aircraft. They have some aircraft have data that's sent back automatically to certain facilities, and they're basically adding pilot reports from various levels of their flight, and that data is also used at times into some computer modeling as well. And the density of the network, yeah, it's, you know, we have a balloon launch here in San Diego. We have one, next one closest is Yuma. There's one up in Medford, Seattle, Glasgow, Montana. So the network, if you think about it, isn't really even that thick, but the profile is thick enough to actually provide some pretty reliable initialization states for the atmosphere.
I could show a map of all the launch sites in the US, or Ryan could. We have it on our webpage, the tracking webpage.
That'd be great. Yeah, that'd be great.
Ryan, you can do that.
Looks like Ryan just did it.
Oh, good.
Yeah, Mark, are you ready to hand it over to Ryan, or did you have some more stuff to show us?
No, I think that covered everything. I just noticed a chat here from Jim regarding please do not return the radio sound to the National Weather Service. Recycle or dispose it properly. Now that's new to me. I was not aware that they did not want them sent back for refurbishing any longer. Again, perhaps Ryan has some more information on that as well, but that's news to me, because when I was doing them, and up until recently, I know that they wanted to go recover them and then reuse them again. So maybe that's also changed.
Yeah, things keep getting cheaper and smaller and faster. But yeah, it's a relatively recent change. All right. So Ryan, are you ready? Would you like to take over here? It's a real pleasure to introduce Ryan Agadminas. He's a senior at University City High School. He started trying to track the weather balloons in 7th grade and caught his first one in 8th grade. His freshman year of high school, he wrote an article for QEX about his findings and has continued to follow the developments of the community ever since. The last couple of years, he's worked as a field journalist for Nuts and Bolts and Servo magazines, in addition to working as a production engineering intern for Gatekeeper Systems. Through school and on his own, he enjoys participating in competitive swim, water polo, mountain biking, and scuba diving. He's planning on studying electrical engineering at a 4-year college in California. He's going to talk to us about station construction, tracking, and the recovery of radiosondes. Please welcome Ryan.
Well, thank you very much for that nice introduction. And thank you for prefacing this with actually why we do launch these radiosondes and why they're in the air all around us. So I'm here to talk today about, how we can actually recover these radiosondes. So the National Weather Service and its international equivalents do not recover the radiosondes after they land. There's a few cases when they launch ones that actually sample the ozone layer that they kind of try and get them back because those are very expensive. But for these everyday ones launched at the 92 sites around the US, there's no official effort to recover them. So myself and a group of hams around the world have been receiving the GPS data transmitted by these sondes and recovering them after they land. It turns out to be kind of like a dynamic geocache because you really don't know where it's going to land until it does. And then once it's landed, you just kind of go out in the field and find this little white box. So you pretty much covered all of it, but a little bit about myself. I'm Ryan Gaminis, Whiskey 6, Romeo Alpha Golf. I'm a senior at University City High School, been tracking for a while. And I work at Gatekeeper Systems at the moment. So the three different types of radiosondes that the US has been using the most for the last couple of years at least is the Vaisala RS-92, the Vaisala RS-41, and the Lockheed Martin LMS-6. Each of these radiosondes has versions that are capable of transmitting at either 400 or 1,680 megahertz. The cellular companies are kind of pushing to get the meteorological instruments off of the L-band because they want to buy up more of that. But because the GOES satellites sit there, it's a pretty established band. But nevertheless, the radiosondes have been getting pushed back down to 400 megahertz in the last couple of years because there's no real reason to have that kind of data transfer for something that only needs a little bit of information to be sent. So let me go back. So we're focusing on the RS-41s today, although you can recover any of these. There do exist open source decoders for the protocols used by all the different models. A lot of people internationally have been working on that for many years. And we're going to be focusing on the RS-41 because that's what they launched here at Miramar, and those are the easiest to recover. So there's actually quite a bit of hardware packed into these little devices. Like I said earlier, they transmit on 400 or 1680 megahertz, less than 300 milliwatts, so not a lot of power. But remember, these things are so high up in the atmosphere, you have perfect line of sight through most of the flight. The modulation varies. The RS-41 uses frequency shift keying, and on that little silver stick, there's some various atmospheric sensors which collect the data that these things are launched to get. And inside, there's a GPS module. The RS-41 uses a U-Blocks receiver, which is a pretty widely used receiver. And the kind of key bit that we'll get to towards the end of the presentation is it uses an STM32 processor, which if you have a background in this sort of thing or you look at it recreationally, the STM32s are a very widely used and reprogrammable processor. So there's some fun stuff we can do with that. The radio of choice for receiving this data is the Rtl Sdr. Now, anything that can tune to 400 or 1680 megahertz, depending where you're at, anything that can tune to that is capable of receiving the signal. But these little SDRs are awesome. They cost like 25 bucks or less. The signal integrity is not great, or integrity is good, but they definitely suffer from interference easily. But from our experiences, they've been more than enough to cover as much range as you could feasibly get out of your antenna setup. They actually originated as a DVB-T receiver. So for European television transmissions, someone built this little thing for super cheap and started selling it. Then while writing the Linux drivers for it, an individual realized that this chip could tune to anywhere between 20 and 1700 megahertz. And these things kind of exploded into the hobbyist industry now because you can only receive, you can't transmit. But for 20 bucks, I mean, that's kind of how I got into this entire thing was for so cheap, you can have a receiver that can tune to so many different things and you can't really do any damage because it receives only. So people use these to track the ADS-B from planes. You can use them as APRS uplinks. You can use them as like get images from NOAA satellites and all sorts of cool stuff. So anyways, for tracking the weather balloons, you're going to need an antenna for 400 megahertz or 1680 if you're using that band, but we focus on 400 because the majority of launch sites use it and they're transitioning to even more using it. I've had great success with monopoles, disc cones, dipole antennas, pretty much anything works. Like I said, the signal comes through pretty clear once they're up in the sky. If you are farther away and you're having trouble, a filtered preamp, there is a great option. There's a couple companies that make them at the moment. I'm actually working with Newelec. I was shooting them some ideas and some technical details because they're looking at making one that would, directly compete with the Upitronics one. But nevertheless, those are also pretty cheap and will definitely get you a clear signal. The radio, again, we're using the Rtl Sdr, and you'll need a computer to run the SDR tuning software and the decoder. What the majority of stations use when we're receiving this weather balloon data is a Raspberry Pi. Make this choice because you can set it and forget it. You set it all up, it connects to your Wi-Fi or through Ethernet, and it'll process all that data for you, and you don't have to be trying to, each day logging into your computer and, taking up that bandwidth. So looking at, cool looking antennas real quick. On the left was back in 2017 what I made. So quick background, they were launching here in San Diego the RS-92s, which are the 1.68 gigahertz radiosondes. They were launching those until I want to say about 2 years ago. And for those, I was using the hardware on the left. That's a helical I made out of some PVC pipe and a piece of like a sheet metal cutout from a trash bin. And then on the left bottom is, the Rtl Sdr with a little tin can that I put a filter in and then a little preamp. And that worked great for tracking those 1.6 gigahertz ones, but we're no longer launching those. Now we're using the 400 megahertz band, which in the center there, I've got a little Yagi antenna on the bottom. I use that when I'm in the field to get, if it's like, on the ground kind of far away, that Yagi might be just what you need to, pick it up from, that extra mile. But the disc cone on my roof is what my home station uses. And after introducing a couple of local hams in San Diego, a couple of which are present tonight, they really took off and started putting up so much better antennas than mine. And now, everyone else's stations are hearing them a lot farther than mine are. But, anything is able to get, with any antenna, you can get into it.
So question, Ron?
Yes, go ahead.
So are you using the small Yagi when it's on the ground to actually track the last mile?
So I don't use the Yagi much, to be honest, but because our home stations have gotten so good at picking up the signal, the Yagi doesn't become very necessary because by time you're at where the home station lost it, a simple whip antenna on the roof of your car will be able to pick it up. But when I was reaching out to companies that were interested in sponsoring me and helping with the project, a couple of them threw some fancy looking Yagis at me. So it's definitely helpful if you're out in the desert and it lands on the ground and your home stations have lost it and you've lost it too, you can sweep around and find it really quickly. The Yagi was essential for, I was using helical as a directional antenna, but a directional antenna is essential for the RS-92s because their GPS completely goes as soon as it lands. Mm-hmm. So you won't have a valid GPS coordinate after it lands. So you have to look at within, a mile radius and then you direction find to find it. The new RS-41s, they don't have that problem. They give you a pinpoint GPS location as long as you can hear the signal.
Great, thank you.
Yeah. And on the right there is, as shown a little earlier, is the station that you guys are working on putting on Palomar. Obviously how, with line of sight, having a station on Palomar with, good antenna on it would, in many cases, be able to pick up that radiosonde on the ground and eliminate the need for carrying a receiver with you when you're going out to try and recover them, which would be very neat. So moving on to the software you need to actually decode the data. In the blue here, this piece of software is called SDR Sharp. This is a Windows-based software for tuning these little Rtl Sdrs. And then So, with this software, in this example, I'm tuned to the 1.6 gigahertz one, but it looks the same process and everything for when they're transmitting on the 400 megahertz band. So in the blue is the receiving software, and then that little white box on the top right-ish is actually the decoder running. And what it's doing is it's hearing the audio output of that piece of software, and it's decoding it and pulling out GPS coordinates. So this works fine, but the piece of software I'm using here is Son Monitor. That's the decoder. It's very versatile and easy to use. However, it's not what we choose to use in most cases because it's proprietary. It's like $20, you got to buy it, and that's not how we roll. So what the Radiosonde Hunters software of choice is Radiosonde Auto RX. This was written by Mark Jessup and Michael Wheeler. They're two Australian individuals who have been super into this for longer than I have. The idea of hunting these radiosondes really blossomed in the UK and Australia long before it did here, just because of the consistency that they were launching at 400 megahertz, whereas over here, a lot of our launch sites were using different types and on different bands, which made it much more difficult. So anyways, this piece of software, what it does, it's pretty neat. It runs on a Raspberry Pi, so totally headless. It just sits in the corner of your house hooked up to your antenna, and you don't need to maintain anything. And so you've got your antenna hooked up to maybe a preamp and then your radio. And then within the Raspberry Pi, this piece of software runs a spectrum analysis, and it looks at it and says, okay, are there any peaks here? And there always will be noise or whatnot. So it marks each of the places where there's a peak in the spectrum, a user-defined set of frequencies, because you don't need this thing scanning where there's no radiosondes. So once it finds various peaks, it checks and sees if each one is a radiosonde. And when it finds one, it starts to decode it, and then it'll give you a stream of GPS data. The reason it has to search for it is because this didn't used to happen here in the US, but now we've matched the rest of the world's idea of the radiosondes change frequency slightly for each launch. They'll be launched on a very different channel, but you're very similar, but like 1 megahertz off channels. So you need this piece of software does a great job of finding automatically where it is and getting you that data. So once it's decoding the data, you have this nice data stream coming out that's not very user friendly. It's a question of how do you use that. So the software suite, Mark Jessup and Michael have done an excellent job of giving you lots of options as to how you actually utilize that GPS data. You can display it on an offline map on your machine. You can upload it to aprs.fi, or the preferred and much preferred method is you upload to SondHub. So SondHub, this website, what it does is, well, let's preface this with, it's very similar to APR. Have you guys worked with APRS websites in the past? It's very similar to that in that you have a couple things transmitting, and then you have a network of receivers uploading it to one website. So very similar concept here. You can see in the green dots, we have all the receivers in our Southern California area. In this case, we've got a lot of us actually now in San Diego, but all those green dots are receivers. And then let's see. Can you guys see the little laser pointer? Okay, perfect. So that little gray dot that I'm circling is the launch site, right where Mark described it, by the 163 and 52. And so when it gets launched from there, the balloon, this is the balloon that was launched a couple days ago, and this is at the end of its journey. So we're not actually seeing it mid-flight. This is what you would see after it's already landed. The balloon over here, you can see followed the path in orange. And, over here is all the real-time data. And when I'm done with these slides, I'll actually show you guys the website in real time, and we can kind of look at some interesting things that happened out in Vandenberg today. But so the reason we upload to this website is you're getting data from all the receivers in the area. You could have data from your home receiver and your mobile one, all uploading to this one website. It really helps in both collaboration and, redundancy. And while you're out on the hunt, you just look at your phone and you see this one map. And you can also upload your car's location while you're trying to hunt them. So you can kind of see everyone, going around the map looking for them. But the single most important feature, and make it or break it feature of the software, is it does predictions. So it actually uses the wind data. If I'm not mistaken, it uses the wind data collected by that balloon on the ascent, and it uses that data that hasn't even been published by the Weather Service yet. It uses that data to calculate where it thinks that balloon is going to land. So this provides you with pretty accurate predictions of where the balloon's landing. It's constantly recalculating as the balloon is coming down after its burst. And this is just like essential when you're trying to find these things, because you need to know ahead of time if you're going to be driving out to El Centro, if you're going to be driving down the street. And especially, if you do choose to hunt one while it's in the air instead of waiting for it to land, this is a great feature because you kind of go to where it's predicted, you park there and you wait a little bit instead of kind of just falling around underneath it. So moving on to how I choose to hunt them, there's a couple of variants. No matter how you do it, it's really fun, but you can, pretty important first step is go on SoundHub, and you can actually click on the receiver near you. This is a new feature. It's super handy. You click on the receiver the launch site near you, and you hit a button, and it'll generate predictions. I'll also show you guys this feature in a minute. It'll generate predictions for the next couple days. And if you see one of those predictions that's going to land near you, you say, hey, so you mark the calendar and go get your chase vehicle ready. So as we kind of talked about earlier, I like to carry a auto RX station in my car. So I actually have a little Raspberry Pi Zero, the tiny little credit card size one. I have that running auto RX, and that connects to my phone's cellular hotspot to upload all this data. And then I also have my home station uploading to SoundHub. And now, we have many more stations in San Diego and soon to be one on Palomar. So, you just put your phone on your dash right there and you have a nice map of where you should be heading. So yeah, you head out, you follow those predictions, and eventually it'll land. And if it lands somewhere accessible, you're golden. Go out there for a hike and find it. I think the center picture was out in Ocotillo by all the windmills. The left picture was no more than 200 feet from the Mexico border, south of just west of El Centro. Barely, wouldn't have been able to run over the border to grab it, but that was kind of fun that it landed so close. And the one on the right was the first one I found that landed out in by the Barona Casino. So they land all over the place. They'll land, a third of the way down the Baja Peninsula. They'll land way out into the ocean, and they'll land almost out of the state to the east. So that's why, running predictions ahead of time are important. So you don't go for too far of a drive when you get caught up on trying to find it. So as I was talking about earlier, there's a lot you can do with these radiosondes after you find them. So to cover what Mark was saying, this is the RS-92. And let's see how my screen thing works. But you see, it's got a pretty neat little helical on there for GPS. It actually worked very poorly for the size of that antenna. I don't know they're relatively old hardware in here. That's why they stopped launching these. But the GPS.
Ryan, I think you're showing an RS-41.
Oh no, this is the 92.
That's a 92?
Yep. So here, I can just turn off my, make sure my room's not too messy. I can turn off my background so you guys can see this properly. There we go. So right here, so this is the RS-92 NGP. There's a couple variants. The NGP, I believe, is the 1.6 gigahertz one. You can see it's got this massive helical for GPS reception, but once this thing lands on the ground, it doesn't know where it is on the continent. So, it was limitations of when these things were designed, probably 40 years ago. In here this is actually the helical antenna. They're right-hand circularly polarized, unlike the 400 megahertz ones. Those are nice and linear. It's got the pretty much same sensor array. And then inside of there is that prepaid mailing envelope. So you can throw it in there and send it back to National Weather Service. If anyone asks, this one's still in the middle of nowhere. I never picked it up. Now, the RS-41s are these guys. This is the new one. They don't look as cool, but they're better for the environment, cheaper and lighter and all that. So, and they can be reprogrammed. But on these ones, it has a nice little sticker, and it says just to throw it away after you find it. Don't bother returning it to the Weather Service. I mean, for whatever reason, it seems like these could also be repurposed, but I guess they've hit that threshold that they're cheap enough. It's not worth refurbishing. But anyways, you can reprogram these because the STM32, you can't dump the old firmware off of it. That's protected. But because it uses an STM32, you can go online for $2, buy the little programmer, and then you use the programmer as a little black thing. And then you can use a USB to serial converter to talk to the board. And you can reprogram these to transmit on the amateur radio bands, because the transmitter in here is actually has a very wide frequency range that it'll operate at. And so you can tell it to transmit on the 70 centimeter band, and you can have it transmit a different modulation as well. So a group, the same individuals who wrote that AutoRx software, have done a lot of work writing their own firmware for these boards that transmits a much lower power and simpler, like FSK. I believe it's also an FSK signal, but and you can launch these again. So the Palomar Amateur, Mount Carmel Amateur Radio High School Club, led by Phil and Randy here, they relaunched 2 of these in the last 6 months or so, and they were able to track them for a ways, and it was pretty neat. Because I mean, in the past, if you wanted to launch a weather balloon of your own, you definitely could, but it was very expensive to get a tracking hardware that would work. So you'd have to be using like a spot GPS tracker. Well, now you've got these things, which plus the enjoyment of finding it, are virtually free. And you can reprogram them to work on the ham bands. And then as we were talking a little earlier about, Randy has one there that he can show off. You guys are working on putting a camera on them that would connect to that STM32 chip and then send a SSTV signal down in addition to the GPS data. And for $8 plus the gas to find the radiosonde, you'd have a device capable of sending images all the way up to the edge of space on a ham band. And they're already super light, already meant to go up to the upper atmosphere. So there's a lot of exciting stuff that's going to be happening and is with reprogramming these and repurposing them. So with that, if anyone has any questions.
Yeah, I have a question. So
Yeah,
I
go ahead.
think Mark mentioned this too about notifying the FAA when you do a launch, and I assume that they need to, ATC tracks that and warns pilots where it may be.
Yeah, Phil or Randy, you guys want to talk about that?
Yeah, I'm not sure about, we haven't notified anyone when we launch them, and I don't know if the Weather Service does either.
Yeah, if you look at the federal air regulations, FAR 101, there's an exempt limit. If you're below a certain weight, you don't have to. We usually do just as a courtesy, but we don't actually have to.
Yeah, and I toured the launch site back when they were launching the RS-92s, and I think in that presentation Mark showed us, there was actually a little picture or a printout on the wall that said, "Remember to call airport." So yeah, there is a for the Weather Service launches, especially Miramar, because they are launching right at the end of the runway. At Miramar, they call for permission before they launch. I don't know if they do that every day now that they're launching remote, or if they've just figured out a schedule. But I know for manual launches, we call them up and say, "Hey, are we good?" And then they might tell you to hold off for 5 minutes or something, but then you let it go. It's definitely a hot topic. Like, what is the risks with a plane hitting these? But the general consensus is, as long as you don't let go of it, like when you see a plane coming, it's not much of an issue, because they're in that band that is the flight path for a relatively short period of time. And that is, another benefit of these ones is this guy used to carry 6 AA's plus, bigger balloon to lift it and all this metal, whereas this guy's a little 2 AA's, thinner PCB and everything. So, when one of these gets sucked into a jet engine, presumably the smaller one will do a lot less damage. Yeah.
Thanks.
Yeah, we call the Miramar Tower, and we also call Montgomery Field Tower. We have to ask for permission first from the Miramar Tower, and sometimes they'll grant it right away. And sometimes they'll say, can you hold off for 5 or 10 minutes? We have a squadron coming in. Sometimes we have to wait. We have to call several times. But essentially within about 30 minutes, we usually get, I'd say 75% of the time we have a go, and about 25% of the time we should have to wait a little bit. So we'll call them at 3 o'clock, which is our launch window for between 3 and 4 p.m. Pacific time. And once we get the go, then we're all set.
Oh, so that explains why you guys haven't been going off at 3 o'clock every day.
That's
Sometimes
the
it's
reason.
right on 3, sometimes it's like a half hour late. That explains it.
That's the reason. Yep.
So I believe you guys should be able to see it. And if you go in the chat, you can actually pull the website up on your own. But this is the Sonhub website. You can see over in Vandenberg, as Phil pointed out, they just launched a Falcon 9 rocket today. And that's why you see all these weather balloons littered in the air, because they launched one. I'm not sure what the interval here was, but, you know, as quickly as every 15 minutes, depending on what they're doing. And so it's pretty neat to see that between our state, we have, you know, somebody up here in, I don't know, near Edwards. We have a couple people in Orange County, and between all of us, we were able to track a lot of these radiosondes as they went through the air. In addition to the, here's our launch site again, that little gray dot. Or it looks like it was, you can set the time interval of, you know, how long you're looking back. And I think it was longer than 12 hours now. So the one from this afternoon, or wait, that should be right. It's here somewhere. Okay, here it is. This little guy in red is the one that was launched by our weather service today. And if you click on them, there's obviously a lot in the air, but it'll scroll down and it'll show you, this is current data, which is, you know, not very helpful now that it's actually landed, but you can view that skew T plot. Now this is not a weather service approved one, but this is what we've actually, let's see, this is what we've collected from the data that our stations are uploading, which is kind of neat. And then in theory, this is very helpful for in the past, a lot of the radiosonde tracking development has been for glider pilots that want that information like now, like while it's in the air. And so, I mean, this is a great unified way that people can get that data. In addition, you can kind of see a cool little graph here with, you know, altitude, temperature, and whatnot. And you can see all their flight paths. And yeah. Any more questions?
Phil, I think you gave a talk once about the radio club at the high school of Mount Carmel, and you were launching ones with solar cells on them, and seemed like they were up for days and days.
Oh, you're thinking of the long duration pico trackers from Bill Brown, WB8ELK. Yeah, we haven't flown those in a while because the balloons we're using have a quality control problem. We got lucky. The first time we flew one of those out of UCSD, went around the world 6.5 times. We've never been able to get it out of the state since. The balloons keep bursting on the way up as they inflate. But that's a totally different kind of balloon and different kind of tracker. It's much, much lighter. It's about 15 grams, which is the weight of a US nickel is 5 grams, which is easy to remember. So those are much, much lighter than the kind of payloads we're talking about here. These RS-41s with batteries are about 80 grams.
Okay,
Yeah, I believe. Go ahead, Glenn.
Yeah, I think thanks. That was what I was remembering.
Yeah, I believe Mark over in Australia, the individual who's really fronting a lot of this, he took an RS-41 and he powered it with a little lithium coin cell battery, and then he attached it to some those nasty silver balloons that you get at Party City, and his managed to make it using the RS-41 as a transmitter. I think it made it well across the country before the battery died, and it seemed to still be pretty high up when it died.
Yeah, very good.
Got a question about that display you had a few seconds ago.
Yeah.
There was all sorts of interesting activity at Vandenberg. There was also something going on at Yuma. Do you know what was going on there?
So I don't, but every couple days or once every couple weeks, Yuma will launch a bunch of them, just like Vandenberg. Presumably, that's before either a sensitive test flight or some form of launch or anything. It's going to be happening in the atmosphere that's relatively sensitive to air, and they want to have a solid model before they do that.
So are they launching the same model and product that the National Weather Service is launching?
So like I said earlier, there's a handful of versions. Now the AutoRx software, as long as it's in the 400 megahertz band, well, okay, as long as it's not a 1680 RS92, those guys are annoying. As long as it's not one of those, yes, the AutoRx software will automatically track it and upload it. So back in that picture I showed you, or on the SonHub website, it tells you what model it is. And it looks like all of those Vandenberg ones were LMS 6s. Those were not RS41s. But I believe Yuma launches RS41s usually. So it kind of depends on the area.
I got a question for Mark. Do you have an agreement with the military when they fly these things? Do they feed the data into the same database as the ones launched by the Weather Service?
I can't say for sure, but I would have to believe that there is an agreement there, since this is international, and it's basically the International Meteorological Society has basically come to an agreement with every country to say everyone's going to share this data and we're all going to benefit from it. So I would have to say yes.
Yeah, I've seen before when looking at databases with the data, there's usually, though less prevalent, they do include data from a lot of airports that only launch them occasionally, and military bases. I know the RS41s have the feature to not transmit until they're at a certain altitude, and then they can transmit encrypted for launching these, at like a forward military base where they don't want to be revealing their location. So it's like, one of their features to transmit encrypted and, not give away the launch site location and all that. But fortunately, the Weather Service does not choose to encrypt them. Otherwise, that would kind of hamper our activities.
It would make it a little more challenging.
It would still be possible with enough
would.
direction finding, but it
That's
would be
right.
harder.
So the final part of the presentation is to show the one that we've been building. This is a proposal that Ryan made a little while ago. And thank you so much, Ryan, for being patient with me as I got it all together and it's nearing completion. So we're looking at putting this on Palomar, and this particular build is over at Paul KB5MU's house. So I will turn it over to him to give us a quick tour of the actual hardware that's going to be of use moving forward.
Okay, I'm going to share my screen to get better resolution on this picture. Okay, there we go. I think this is going to work. Okay, are you seeing my hardware?
Almost. It started the screen sharing. Yeah, we see it. And I think we can hear you too.
Well, that's good. That's a good combination. So we discovered from putting equipment outside for other reasons that Raspberry Pis get warm. And if you close them up in a weatherproof box, which you kind of have to do to keep the weather off them, they get hot and then they stop working. So the plan that this has worked really well for us in the past, and I think it'll work well for this too, is an aluminum plate mounted on the back through a big hole in the plastic enclosure that would otherwise be weather tight. And then the Raspberry Pi goes into a standard case. This is a Flirk case that are available off the shelf. It's aluminum and it's got the shape molded into it so that it can make contact directly with the processor chip on the Raspberry Pi. And that's bolted directly to the aluminum plate. And that makes a pretty good heat sink. It keeps the temperature of the Raspberry Pi down well within tolerance. There's that same preamp with the filters in it that you saw before. The Rtl Sdr is here. It's kind of hidden under this bracket because it's also bolted down to the cold plate in order to make it not get too hot. And then you can see the U-bolt sticking through here for mounting the thing on a pole. and everything's powered through the Raspberry Pi, through the standard wall wart that comes with a Raspberry Pi and an extension cord. And that's the hardware. This particular build is not yet fully weatherproofed. It's just a matter of adding some goo here and there to make it sealed. And then you can close the lid and latch the latch, and even lock it if you want. And that's weather worthy. And we'll find out whether it's mountain worthy when we put it up there.
Yeah, I think Ryan has also has a preamp. So he would like to include a preamplification. And you might want to talk a little bit about the antenna.
Yep. Paul, this is Mark. Oh, this is Mark. I got standard stupid question because I have to keep equipment running up there also. Most of these devices are 0 to 70 degrees C. When I was doing military stuff years back, we had a problem that a cold plate would actually make the processor so cold you'd get it under 0. Any concerns?
Well, that's an interesting point. It could happen.
When it's 0 degrees F up on the mountain.
We'll find out, I guess. I'm not able to test that hypothesis here in Carmel Valley. But the Raspberry Pi makes enough power, I think, to self-warm itself adequately. Also, that big silver box in the middle, the one that says 403 megahertz on it, it is a preamp as well as a filter. So the only feed line involved would be between that spot at the bottom of the big silver box and wherever your antenna is. Hopefully that feed line will be kept pretty short.
Yeah,
we probably also want to keep. Go ahead, Michelle.
Oh yeah, I was just the feed line with your first antenna was significant. So it was just to get it up and on the air, but it was quite a bit of feed line.
It was a couple hundred feet of feed line, which is kind of a lot at 400 megahertz, even though it was decent feed line. And the actual performance was pretty much the same because line of sight, it's not a weak signal really until it gets right down onto the ground. If you're trying to go retrieve them, that might be a problem because the difference between tracking it down to 8,000 feet, tracking down to 5,000 feet would be significant. But for just looking at the maps and collecting weather data, doesn't really matter. We probably do want to keep this off the repeater site, though. The Raspberry Pi is not going to be super quiet from a radio point of view. So we've got another location around the corner from there that should be less challenging for the radio receivers.
Yeah, and we do have an antenna, I believe, and yeah, we'll share updates with this through the newsletter and through the Facebook group, and looking forward to getting it on the air and figuring out all the interesting things throughout the year, like Mark raises with the temperature.
Question, Paul. I don't see an Ethernet cable. We're using Wi-Fi to talk out the box.
Yes, when this picture was taken, we were using Wi-Fi, and Wi-Fi works fine here for this purpose. I did have some concerns, and I ran an Ethernet cable, and that worked even better.
Yeah, I use Ethernet with power over Ethernet to on the Pi and the preamp, and that would save some bulk up here. Another advantage of PoE is that you can cycle power very easily. If you already have a managed switch, you can usually drop power to the port through administrative interface and power off the Pi that way if you want.
That's a good suggestion. The PoE is an extra hat that goes on top of the Pi, right?
Yeah, you can get hats. I've used both. I have a hat on one of mine, and I have a dongle splitter that goes on the other because it was too old a model to accept the Pi hat. The Pi hats have fans, which I have mixed feelings about.
Yeah, I have completely unmixed feelings about fans in this situation. They're unacceptable.
I actually agree with that.
Well, thank you, Paul. I appreciate it. Do you have anything else to share before we close?
That's it.
Paul, you might want to consider the way we solved the problem 100 years ago is we put a couple of Peltiers underneath between the heat source and the cold plate, and then just temperature controlled the Peltiers, turning them on and off or whatever. And that way we didn't get them too cold, because when the Peltiers are off, they're actually pretty crummy thermal transmitters.
if it comes to that.
I have another question.
Sure, go ahead.
So I assume that when the balloon bursts, it's up 50, 60, 100,000 feet. How long does it take to descend to ground at that point? And does that give the Weather Service a different picture of the weather, the pattern that is going through?
Yeah, so the Weather Service actually stops tracking them as soon as it bursts. I don't know particularly why this is. I've asked them about it in the past, and they just kind of said, this is how we do it. I think it's because when the balloon bursts, it can damage the instruments and adds a lot of unpredictability. But yeah, the Weather
filter
Service,
that out of their data stream.
yeah,
anyway.
yeah. So they stop, and in theory, they've already got the data because it went up through it. They don't need to go back down through it. So the Weather Service stops tracking them when it bursts. Obviously, we keep tracking them after that. It depends on what hardware they're launching, what kind of balloon they launched, and most importantly, if they have a parachute. The RS-92s had parachutes, big red ones, and which made it a lot more fun to find because sometimes you'd like be on the ground as it's drifting down, and you can try and catch it. Haven't quite caught one yet, but at least the RS-41s they launch here have no parachute, so they come down at up to
terminal velocity.
yeah, pretty fast.
I've seen them go well over 100 meters per second when they still burst, but by the time they hit the ground, it's somewhere between 10 and 15, and it seems to depend on how much of the balloon is left. Sometimes you get most of the balloon, sometimes you just get the neck. Yeah,
exactly. So I mean, at 10 to 15 meters per second, you can do the math, but I haven't actually, paid much attention nowadays. But Phil, how long would you say it is after burst on the new ones?
It's about 20 minutes. There's a timer on the RS-41 called a burst timer that starts when it senses itself falling, and it runs for 8.5 hours. So you got to get to it before 8.5 hours after burst if you want to hear it on the ground, if you don't know exactly where it is. Speaking of mountaintop receivers, a bunch of us, Randy and a couple of the guys from the Mount Carmel Club put a receiver up on Toro Peak a few months ago. It's working really well, although it needs a preamp to hear better. But it's often hearing them right down to the ground. And Randy has been recovering quite a few of them thanks to that information, rather than driving out the night before to get a fix on it and then coming back in the morning when it's daylight, which is not very practical. So we're going to have the mountains around here covered pretty well. Randy's got another one on test right now at his house that's going to go on Mount Otay pretty soon. So between Otay, Toro, and Palomar, we're going to have this pretty well covered.
That concludes our program for the evening. I think we can turn the floor over to open discussion and questions. And let's let Joe, if you wanted to say anything at this point, or.
A really interesting presentation. Thank you both for the presentation, and lots of good discussions, lots of really relevant questions, and really really informative responses there. Sorry, I was just reading some notes in the chat there. There's people thanking for the presentations, and yeah, this is fantastic. We did stream this to YouTube, and it will be available in our YouTube webpage, YouTube site for forever. So people can go back and rewatch the presentation if you missed parts of it or wanted to re-listen to some of it. Thanks, Michelle, for setting this up, and
You're very
great.
welcome.
This is the time to just open it back up to general discussion, as Michelle mentioned, and we'll leave the meeting up until we dwindle down to the last few people. At this time, I'm going to go ahead and stop the live stream and recording, though.
I've got an interesting observation about the Vandenberg launches.
Okay.
Maybe you can explain to me, because they don't go up in bursts. They go up and dwell at about 17,000 meters.
Some of them, and that's a very good question. This is last time, and last time they sailed right over LA and Orange County until the batteries ran out, and it looks like something similar happened today until most of them went to Mexico. I would very much like to know why that happens.
And how it happens.
Yeah, it depends. I mean, obviously on the balloon, if they're underfilling larger balloons because they want, likely if they're launching rockets, they're looking for more data at a higher atmosphere. So maybe that's why they look for that spread. And I mean, that can be accomplished, from my understanding, you underfill a larger balloon, and then as it, goes up, it's bursts much, or it'll ascend slower at that higher altitude and then, be less prone to bursting.
If some of these have been up for hours after the launch, that doesn't seem very useful to them.
Yeah, I know.
Well, it gets you horizontal coverage, right? As it drifts. If you pick your altitude, you can control which way it goes, even to some extent.
To some extent, yeah. I mean, today was a sun sync launch, but the balloons came south and then went southeast, as you saw on the map. I think they're mainly looking for wind shear. You just want to make sure there's no abrupt change at an altitude that cause, excessive stresses in the launch vehicle, especially around max Q.
It's really fun to play with these observations. It's a lot of data that you don't usually get to see.
Absolutely.
All right. I have a question for Mark if he hasn't left yet. Mark, would you